My name is Mr. Toby, and if you are viewing this message, then I need your help to escape from my foes in the calculus world. It all started on a sunny day at Hazlitt High School. I was teaching my calculus class and all was calm. I know my students, and they yearn for the knowledge that I possess. Bright young minds, limited by corrupt and evil college board. But one day, something began to change inside of me. I had to teach the truth, a more complex calculus. A man approached me and told me it was forbidden. I refused to listen, and I had to continue on. I started seeing their faces wherever I went, but my students grew stronger in their calculus skills by the day. The evil that lies in the college board can never win, and it is my job to expose them to the world. On that fateful day, one of them followed me and convinced me to go with him. Little did I know, this was a grave mistake. They took me by plane to their headquarters, but I was not going to go down without a fight. I jumped from the ruins of the plane to the small farm town of Dubuque, Iowa, but the board summoned their forces from the Illuminati to find me. I knew what must be done, and I began to flee into the cornfields that surrounded the area. Back in the day, I was a professional track athlete, but now I need a little more power to escape this conspiracy. A machine capable of speeds unknown by man. The college board forces closed in around me, but with a thunderous roar, I began my escape, driving into the unknown, knowing that my mission was not yet complete.
Mr. Toby's tractor has a cone-shaped gas tank with a height of 3 feet and a radius of 1 foot. If the height of gas remaining is changing at a constant negative 0.3 feet per minute, what is the rate of change of the volume when we have 2 feet of vertical gas remaining? So the first thing we want to do is identify our formula for the volume of the cone, which is here. The second thing we want to do is identify that the radius of this cone is 1/3 of the height, because the height is 3 feet and the radius is 1 foot. So our radius is 1/3. Right. This will be helpful because it puts the equation in terms of h. So we're going to go up here and simplify our new equation, which is pi h over 3 squared times h over 3. Then we're going to simplify this down. Squared 7 times h over 3. 5 more. 5 or 9, 7. And then the next thing that we're going to do is take the derivative of this. So this is our volume formula. We're going to take the derivative of that equals squared 27 plus derivative of the height here. So we can simplify this down to pi h squared over 9 times dh over dt. Then all we have to do is plug in our two numbers, which is 2 for the height and negative 0.3 for the rate of change, which is so pi over 9 times. And then this gives us approximately over dt equals negative 0.419